Hi all, welcome back on my channel. Today we are going to speak about the CAM software, and we are going to work with FreeCAD, and there is a special workbench that is dedicated to the CAM operation. So the first thing first, I want to show you which version of FreeCAD I am using. So it's the 0.7 and the revision is 3509. So it gives you an idea about the status of of the FreeCAD development. So I take the previous part that we made, and I will show you a good way to make some CAM operation and to make some machining operation. So let's say that we have a 3-axis machine, and we want to machine these parts, and I will show you different kind of operation that we can make with this kind of CAM software. So the name of the workbench is Path. So you click here. So if you come from another workbench, you just have to select Path, and it's the name of the workbench that is able to generate everything around the CAM operation. So the first thing first, you have to create a new job. So for doing that, you just have to click on this icon, and the system FreeCAD is asking what base model you want to use. So it's indeed a part testing for this one, and you can use some templates, but it's too complex today for what I want to show you. So let's make it simple and go this way. Just say OK, and then you have a dialog box that is open, and you can see different things. So the first thing that you can see is a box that surrounds the parts, and the dimension of the box is 1 millimeter over its dimension. So it does mean that you have 1 millimeter on the X on both sides, 1 millimeter on the Y, and also on the Z. So you can check from the upper side or from the side. You can see that the let's say the stock is 1 millimeter. I think you can change everything that you want. So if you want to put this kind of stock in a vise, we have to increase here the Z parts of the model. So let's say that we have 10 millimeters on the downside, where the vise will take the stock, secure the stock on both sides. 1 millimeter is okay, and sometimes there is some question about the origin. So the origin of the part come from the design you create. So for this part, I don't know if you remember, but the 0 for the X and Y was in the middle of this distance of this one also, and the Z0 was at the bottom of the part. So let's say that we want to change the thing regarding the machining we want to make, and for example I will select this vertex here, just the point, and it's the place where I want to put my 0. So when I select the vertex, you can see that those two boxes are able to be selected. So I will say that the elements will be set to this point. So as you can see, the part did not move, but I will show you that there is some confusion with the previous model, and we will go further on this side. So for the moment, let's say that we change the Z position at the top of the stock, and the XY 0 will be on the left side of the stock. Another thing that it is useful to create at this step regarding the output is the type of processing you want to make. So I use Linux CNC, but you have all different kind of things. So I will set a machine, I want to use Linux CNC, and I will give a name to the output file. So also check where you put your file. So in this case, I will let the file be created here, but I will move further. You can choose where you want to put this output file. So just put a name, The extension is NGC for Linux CNC, and you can put also some arguments, but it's too complicated today, so I will not discuss about that for the moment. And regarding the general things, you can put also some comment here if you want. So for the moment, we are fine with that. We define the stack, we define where the zero will be for making the machining operation. So let's say we are agree and click OK. So the first thing first, you see that the part disappear, and there is a big confusion between the CAM software and the CAD software. So what you see here is the part from the CAD software. So if I mask the part, I can see that I am inside the CAD software where I create the parts. If I go inside a job, I have another part, and this one is that we call the base part that is used inside the job. So what you have to know when you make some CAM operation is always based inside the job. So you always have to use the base part testing. And you can see that the position is not the same, but there is an explanation about that. If we go to the top, and you will understand in a couple of seconds, if I show you the stack, you can see that the corner, the bottom left corner of the part is in the middle of this one. So this one is the CAD part, and this one is the CAM part. So to avoid any confusion, when you have created your job, that you have to do, you have to mask your CAD, parts. So you only work now with your CAM part that is selected inside, the job here. So it is a thing that is critical to understand, because sometimes if you mix the part design and the machine parts, you can be frustrated because you will not understand why the system creates such thing. So the best thing is to mask, the CAD part, and you work with the CAM software inside a job. So we are fine with that, and you see also there is some default tool. So you can create your own library tool, and I will only show you one or two examples of creating a tool. But you can import and export, a tool table that is very useful. So if you want to create a tool, it's the good time to do it before making any machining operation. You have here the tool manager, and let's say that I want to create a new tool. So I select new tool, I give a name to the tool, so let's say end mill, 8mm for example. It's end mill, I'm fine with that. Carbide, okay. Diameter, I put 8mm. You can put a lot of detail regarding the tool, but basically we are going to make it simple. So you put at minimum the diameter to make the path calculation, and also the type of cutting edge. So let's say 15mm height, about that, and say OK. Then you have to select the tool. It will be the tool number 3, and you click here to create a tool controller. So you can see inside your job that the tool number 3 is an end mill with 8mm. So I will create two new more tools that we will use at the end, just to show you what we can do with this kind. So let's create a drill bit. Let's say drill 3mm. The type, it's a drill. Let's say carbide, diameter 3mm. And for the cutting end, let's say for example 25. Let's say OK. And let's create also a small end mill. So let's say, so I will add a tool controller, so the tool number 4. Let's create a new tool, a small end mill 3mm, diameter 3 cutting, let's say 15. Here it is. We create a tool controller, so we have basically three tools inside the thing. So you can import, export the tool library, and so you will not have to create the tool each time. I will not go through those import and export thing, but it's very useful to create once your common tools, and then only use them when you need. So now I'm fine with the tool, so I will say OK, and we will create a first operation. So let's say that's the first operation we want to make is a surfacing here. So here it is, the stock, and we want to make some surfacing here to prepare the surface for the other machining. So you have different type of icon here that creates different type of machine operation. So we will create a facing operation using this icon, and the first thing that the system is asking is what kind of tool you want to use. So let's say that we will use the 8mm end mill, and then there is some different type of information that you can fill inside. So the base geometry, you can use add a face, and the system will work with that. Then you can control the depths of what you want to make. So for example, we start at 0, the final depth is -1 because we define that the top of the stock is the Z0 and the part is 1mm below the Z stock, so it's a final depth of -1mm. It's the finished depth, it's at 0, and the step down, you can change the step down, let's say 0.5mm, say OK. And inside operation, you can change the cutting mode. It's conventional or climbing. Let's say climbing. The kind of pattern zigzag, the step over, and you can also let some more materials to make a finishing operation. So if you agree with those parameters, you just say apply, and you can see here the path of the tool for this thing. You can change whatever you want and click to apply. So it's a good way to see how the path is working. For example, if I say the stock apply, I will increase the surfacing operation, and I'm sure now that I will go everywhere from the thing. You can change also the angle. For example, you say zigzag. If you want to put 30 degrees, then you make apply, and as you can see, you change also the thing. So you have different type of pattern. I don't want to go through all those things, but I'll give you a general ideas. And also you can see that there is some different colors, and the red one is the rapid move, and also the green one is the machining operation. If I click on OK and I go through operation, I have a milling phase. Okay. And another thing that is useful, if you want to define the speed, you have to do it inside the tool controller. So here you can see the size of the tool. You can define different things regarding the horizontal feed, the vertical feed, the rapid horizontal and vertical, but in Linux CNC does not use those things. You can also define the spindle speed. So let's say that we want to fill those things, but if you look at the units here, I have millimeter per second, and generally even in metric things we do not use this kind of thing. So we have to change the units, and the way to do it is very simple. So let's say we are okay with that. You go to edition preference, so the system will upload, and then you have here a big icon path. So you can change, you know, things around the path, but if you want to change the units, you go in general units, and you can see here I have so the metrics, millimeters, kilos, second, degrees. I can change that, and if you click on the small parts and CNC, I will have millimeters per minute. So I will use this one, click apply, say OK, and now if I go to my tool controller, I have the proper unit I have to use, and you will have the same thing, you know, in the imperial unit. So let's say that the horizontal feed is 250, the vertical feed is 80, and spindle speed 10,000. Say OK, and so the speed are defined with the tool. So it's one way that we define the the first operation. So the face mill now is done. You can let me check how to. So you can remove, you know, the pass just by clicking on the space bar like that. So, and you see that there is two lines, and if I go there, it's because we have 1 millimeter depth, and we choose a step down of 0.5. So that's why there is two, you know, line. The first one is the minus 0.5, and the second one is minus 1 millimeters. As you can see here also, if you go on a path, you have a small arrow that show you in which direction the path is working. So it's pretty nice feature. So you can understand that you go from this position to this one and so on. So let's say that we are okay with the mill face. And a question that you can have regarding this one is how we can define, you know, this let's say the safety Z. And here you have a setup sheet, and in the setup in this setup sheet, you have some safe height and safe offset, where you can change the dimension. So you have the clearance, you can say 5, 10, whatever, and the safe offset also for operation heights you can change here. So if you change those value, you will change, you know, the position of your tool. So it's the place where you have to go to change that. Okay, so let's do the next operation. So here we do have a pocket. So let's create a pocket. So the pocketing operation is here. So create a pass pocket object from face. So I click here. I will use, you know, the small end mill. So let's say the 3 millimeters end mill, and I will say OK. So the first thing, you have to add some geometry about that. So I will use this one, this one, and this one. So I select, you know, geometry I want to use. So I take the side, because with the side the system will detect automatically, you know, the dips of the pocket. It is a pretty useful thing that FreeCAD use. So for the depth, so as you can see that he already, you know, understand that it's a minus 16. If I want to change the step down, and I will change the step down, and let's say I will step down only 1 millimeter. So I do it like that. Then you can change the safe height and the clearance height, or if you don't want to change each time, you go to the setup sheet that I showed you previously. So I will let those one like that. I'm fine with that. And then here I am in the operation where I can define the thing that I want to make. So the cutting mode, let's say clean. It provides a very good finish. The pattern zigzag, for example. And if you are fine with everything, step over maybe a little big, let's say 60 millimeters, 60%. Sorry. Then you click on apply, and it is supposed to. Okay. So the pocket does not run, so it's suppressed this one, use a new one. You know, FreeCAD is not really stable. Yes, I will do it another way, so I will select that. Say I want to make pocketing operation. Default tool is -3 millimeters. Okay. So geometry is now okay. Dips we change with 1 millimeters. Okay. Safe eye. Okay. Operation. Line. Apply. There it is. I don't know why it does not want to work with the previous one, but here it is, the result. So you see the pocketing operation. We can change the parameters, you know, with the step over, the angle, position, and so on. And here we have a pocketing operation, so a pretty nice one. And also, as you can see, we have 1, 2, 3, 4. It's based on the fact that we need, you know, 4 step down to make the pocketing operation. So here it is. Let's say that we are fine with that. So we have the mill face, the milling face, the pocketing operation. So now let's do some, you know, some drawing operation. And the way that you are doing that is the following. The first option, and I will show you 2 options to make it. The first option is to use, let's say, the drawing operation. So I will use the 3 meter drill. So I say OK, and here I can select, you know, some geometry. I say add. So all the geometry have been added. So now start dips, final dips. So let's say, for example, the final dips is minus, let's say -5. I do not remember, you know, the size of the thing, but let's say -5. So say like clearance size are the same. Operation. So you can add some peg drilling and dual drilling. So I will not use for this option, but you can do it. So let's say I'm fine with that. Let's say apply, and you can see that you have the drilling operation. And maybe it's not deep enough, so it's not a big concern. We can see here that it's the final result is not at the bottom of the hole. So I will change only the depth and say that the final depth is a -6. Okay, apply. Okay, and as you can see, I go through the bottom of the thing. So you can change the parameters or whatever you want. So it's one way, but but imagine that you want to do it another way with a small, you know, smaller end mill, for example. So I will show you another way to create holes. So sometimes people like to make a drilling operation and then to make the finish hole with a small helix inside. So it's possible using this function. So it's a helix object. So I will use the small end mill, the 3 m 1. Say OK. So the system already kept, in memory all the good information here. For the depths, final depths, let's say -6. Step down. So it's the step of the helix. Let's say 1.5. Sorry, 1.5. Okay. Let's go back to the correct position here. Okay. Say 5 clearance side. I'm fine. Operation. So you start from the inside. You can choose the direction. So it's clockwise. You can go in the other direction if you want, and you have the step over. So I click on apply, and here's a concern. Step over, let's say 45. The end mill, I guess the end mill is too big regarding the size of the holes. That's why he has a concern to create the operation. But you have the idea about that. You just have to create a smaller end mill regarding that. So I will remove this operation because I need to create another. So yes. So basically we have facing pocketing operation and some drilling. So all three operations are watchable here. And the last thing that we want to do is to make some contouring operation. So to make the contouring operation, you can use this option or this one based on the object. So we'll use the 3 mm end mill. Say OK. So final depth -6 sounds be OK. Step down, change that with 1 mm. Save clearance side the same. An operation, you have the tool here. You can use compensation or not. It depends on the thing that, and I will explain that. So as you can see here, the path of the tooling has an offset of the half diameter, of the tool, because it calculates with the compensation. If you remove this option and you click on apply, it will create a path, directly on the part. It's not a concern because if you activate the tool radius compensation on your CNC, then the machine will do by itself, the compensation. It only depends on the kind of strategy that you have the habits to work with. So you can use, the both thing, this one or the other one, but those two one are usable. And for the dips, I don't want to go through the vise, so I will say that I just go to -6, apply, and as you can see, it's only the portion of the part that I want to machine, so I will not affect the vise on this side. So I say OK. So I do not take special care about the machining, thing like that, but I just want to show you the idea about that. And so now that I make all the type, of machining, let's say that we are pretty happy with that. I don't go with the condensing operation, but you have just to create a tool with the proper angle at the end, go the proper dips, and use the drilling operation. It will be done. So if you want to check, your G code, you can use this icon, and so you say job, click here, you save the file, and you have your G code here, and it's the post processor is quite nice, because at each step it tell you beginning operation mill phase. So you find here the operation that you create. You can make the name whatever you want, and you will refine you know, the name here. So you see also that you have the good you know, units, so millimeters per minute, and also you have a preamble, so J79, J50, J40, J49, J80, J90, J21. So it can be complicated for you, but it's very simple. And if you want to understand what is this kind of G code, you just have to go you know, on Google, you use the website, and you type Linux CNC G code, and you will have a summary, you know, of the G code. So you can see, yes, it's very simple, and it's very easy for you to understand that it's basically some function that you activate or not regarding, you know, the preamble here. So if, for example, we are looking for J17 to understand what does it mean, you can see here we have the plane selection, and J70 is the X and Y plane selection. So for the machine it does mean something important for you also, because we work on the X and Y, you know, on the part here, X and Y. A lot of machining operations are made on X and Y. So the plane for us is indeed X and Y. It could have been different, but in this case it's X and Y. And we will check another one, the J21, for example. It's just define the units. So the way FreeCAD is designed by using, you know, the millimeters. If I had working with Imperial, I will have used, you know, G20, because G20 is for inches and G21 is for millimeters. And it's the way that the post processor is using that. You can, it's a, you know, it's a text file, so you can change everything what you want here. Interesting thing also is the fact that you see M6V3. It does means tool change with the tool number 3, as we define here also. So if you have your tool table defined in Linux CNC, you can create it in FreeCAD, and it's very useful. Then you have all the moves, you know, from the machine to make the milling operation. And if you go down, you can see that you have the pocket shape, and with the pocket shape we use the tool number 5. Here there is something interesting. So with the tool number 5 you can see M3, that is the spindle start, S0. It does mean that for the tool 5 we do not define any spindle speed. I go too quickly, and that's why I have 0. So it's a good habit to check the G code and not to go too far with that. And all the rest of the operation are inside the file that is already defined in the job operation. And then you have a post number, you stop the spindle and stop the program, and so on and so on. Another option that can be useful for you, there is some simulation. So if you go here and you launch the system, you will see that how the parts will be made, you know, with the system regarding all the machining operation. So it's pretty useful, you know, tool. You can see how the part is, you know, is made. You can see if there is some strange thing. For example, here we have to check that the pocketing operation need to be made in a better way, and also we have some remaining material here. So some finishing operation have to be done here, but as I do it very quickly, I do not take special care about the machining to be sure that the part is made. So basically you make a roughing operation like I make here, and then you have to make a finishing operation and to be sure that everything is nice and clean. And also when you have make some machine operation, you have to make some chamfering operation. For example, small chamfering around the pocket, and chamfering here also, to avoid any burrs, and not to cut the people for that. So here it is, with the past operation. I hope that it will help you. It's a very helpful tool. A lot of people works on FreeCAD and make a really great job, because this tool is very easy to use. You can create a lot of things, and the spirit of a machining guy is very well implemented here, and it's not very complicated to understand how those things are created. And also you have the CAD software that helps you to create the part that you want to use. So thanks for watching. Hope you had learned a lot of things about the CAM operation, and hope it will help you using this device and for the machining operation. So thanks for watching, and stay tuned.